Hey everyone, today we're looking at this Ford Fairmont EF model climate control module, and apparently I'm not sure what doesn't work about it, but something's burnt inside. I guess it made a smell or some smoke came out of it, I'm not sure, but that's what I'm told. They're quite expensive if you can come by one that works. So we're going to see if we can get this one going for the person who owns it, given that it's apparently suffered a major failure. I'm not going to try and apply power to it. I think I know which pins it is. I think I found a valid connector pin out online, so we'll keep that in mind. We can trace it through to see if we're right, but let's see if we can get this thing apart. Looks like it's going to come apart fairly easily. Just a few little clips. It's quite a rigid frame. You need to release at least 3 of them, it feels like, just to get anywhere. Then of course holding it so it doesn't spring back in. It's always the trap. Okay, I think it's far enough sticking out the top there to hold itself, and then we've got a couple at the bottom, and there it goes. I'm not sure if these light bulbs here, I guess they just sit there. They shouldn't have any impact holding the board in. Oh yeah, okay, so the connector's sliding out with the board, and looks like the wires are, we might have to disconnect the bulbs. Looks like it's all going to come sliding out with it, I think. Yeah, just like that. You kind of smell it from here. Oh, there it is. Okay, let's go in for a bit of a closer look. Actually, that can unplug from the front. That's handy. There we go. How about that? Just keep in mind what way round it goes, because I think it can go 2 ways. But, oh no. No, you'll be right. It can only go 1 way. You won't get the cover on if you try the other way. There's a bit of an overview. Capacitors are shielding the light. So if we go like that, you can see a nice big black mark down there. So that's going to be interesting to see what's actually caused that. The underside, there's a little bit of goo there. There was something going on at the bottom of that capacitor, so it's probably just maybe a failed capacitor. Maybe it's blowing out or something. Certainly looks like the flamed in that direction. Yeah, not too much going on. There's a lot of actuators that are controls for airflow and such, and they're probably controlled by each of these transistors. It would be a shame if that was damaged. I doubt it would be repairable if it was. It may have onboard code which you'd never get. Yeah, it really looks like the capacitor's just ruptured, which is interesting. It's unusual for that to happen. It's almost like it was powered up backwards, or maybe there's a bit of ripple on the line or something. It's a bit strange, isn't it? With any luck, it'll just be a simple replacement of that. We'll do a check on the other caps, but at this stage, maybe that's all it is. Clean the soot off, which could be affecting things. So let's remove that one and have a bit of a clean up. Having a look at the underside, that's quite interesting. The solder around that pin is like almost non-existent. It hasn't let go because I'm wiggle it, and yeah, it's not moving. But you can see it's the trace is lifting off the board, which is unusual. You can see right there, it's actually come up off the board. Almost like when the cap's blowing out, the pressure has gone down around the... Whoa! Can you see what I see? There's actually... This has gotten really hot, and the solder has gotten molten. And look at the little solder. There's solder splatter for miles. Okay, so if we have a look here, we've got solder blobs, solder blobs, solder blobs. Okay, coming up here, we've got little solder balls everywhere. Alright, and then looking over here, we've got more solder balls here, 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 here. Oh, there's another one up here. Another one here, another one here. That's impressive. So we've got, it's hard to see when you zoom out, but we've got shrapnel pretty much in this whole area. Little solder got blown, so the cap got really hot, it melted the solder, and the pressure built up in the cap released down through here, which lifted this copper trace and push solder out everywhere. That's pretty cool. And here as well. I'm gonna wiggle out. Not quite loose enough. I should have used the old tried and true method. That is pretty spectacular, I have to say, for a cap failure. What are we, 100 mic at 50 volts. Should have something around here that'll do that. Try with a bit of ISO. See if we can erase most of that. Seems to be coming off alright. But it would have been very conductive. And it's blowing in underneath this. So this is the little crystal for the clock generation for this chip. And because it's surrounded by carbon under its legs there, it probably isn't functioning, so that chip probably isn't running as a result. Might have to get in there with something a bit harsher to scrape most of that off. But because that board is actually turned to charcoal, we might just have to dispose of it, cut it all out so that it's not conductive and causing a problem. Yeah, you can really see the layers. Well, this is only two-sided as far as I can tell. I don't think it's got multi-layer. We'll wipe most of it up and then we'll give it another wash to make sure we flush it all out. Do I take that off and to clean under it, and might just hose it with some contact cleaner? Ugh, she's pretty dark under there still. I think I will remove this and then we can just make sure we clean it properly. We'll pop some fresh solder again on that little crystal, if it is a crystal or a ceramic oscillator or something. One way or another, I'm gonna get you. Aha! I should have been a dentist. Now let's see if it's got a marking. It has a couple of markings, but we want, oh, it's got some lettering on it, so we want that to go facing the chip, just in case it has a polarity. Never dealt with one of those. Let's see if that carbon is conductive. Oh, maybe we washed it away too much. Oh no, there we go. Look at that. There would have been more before we were washing at it, so that would have most definitely been interfering with the clock signal. And then if we probe around in the burnt section, yeah, it's down around 130 ohms. This has to go. We have to chop it all out, like the cavity version of a dentist in the electronic world. So I'm thinking we dig up this trace and to isolate this pin, so this is the positive pin, the negative connects through on the top of the board, and it's fairly clean. We can connect through to there, but I'm thinking what I'll do is, yeah, cut this trace up completely. We'll drill a hole there, and then we can have the lead of the capacitor come through, and we can reattach it to these 2 points here. So that's a diode. That's a diode across here, and that's one on this. This is probably some sort of voltage regulator as well, multi or single or variable or something. But yeah, this is bubbled up, so there's probably a lot of carbon underneath there. I think we'll just start having a dig and see what we can see. It's really stuck on there. So that's pretty much all the way through. I'm pretty sure there's no inner layers. I think if we drill that through and then play it by ear and see what we can, what sort of game plan we can come up with. Alright, what's a good sized bit? What have we got? Quite a biggish hole. Maybe we could start with that one. That is 2mm, maybe go 2.5. No, that's 3mm. About 3.5. That should take a fair chunk of it out. Let's do that. Should probably get a vacuum. What does the other side look like? Alright, I think we may need to go a bit bigger. It's still a bit charred in there. We may need to go one size up just to try and clear out the majority of it. We'll take it up to 4, so another 0.5 millimeter. Let's see if I can clear off some of that black, especially up towards the top left. Bit cleaner looking, a little less carbon in there. We'll clean up that chewed up copper. Might be able to just trim it off. Likewise on the underside. I'll trim that round. So I'll just take a resistance measurement from, say, here to here, and it's going to say 3.6 k ohms. Now I don't know, it'd be hard to know if that was linked to carbon in any way, but I suppose if we checked it closer to it, and it was, it would be lower. No, okay, it is. Actually, sorry. Probing on this carbonated area, I'm getting about 10 to 20 megohms through to this trace. So we do need to chowder that out some more to make sure that that is not conducting through there. So we've chewed that out some more. It's looking like a whole lot less carbon there. So probing the carbon, what's left of it, to see if we get a connection. Make sure we get nothing around here. What do we get? Now as far as the wall thickness and any carbon that might be there, I have no connection. No connection through at all. The only connection is when I'm down around this copper, and I've got the normal circuit resistance of about, it's coming up at 3.6 k still, but at least I know for sure that that's not interfering with it. Be sure to clean what's left of that up and see if we can find a cap. It's all going to flake off, isn't it? It's all been overheated. You can always re-mask that. I feel like I want to remove that little resistor down there. It's got carbon blowing around underneath it, which is going to be affecting its value. It's, yeah, might be safest just to remove that as well. Might just be able to heat this one off the board without hot air. There we go. There we go. Oh, no. Try that again. Don't squeeze too hard. You might flick it across the room and you'll never find it. Now I'll clean up one side to make it a bit easier. That's how you can get it to sit nice and flat on the board. You've got one side's already flat, the other side's got your solder on it that can hold it into place, and then you can solder the other side. Perfect. We'll replace it with a 100 mic 63. That will be just fine. I'll clear that hole hopefully, and we can pass the cap through and see what we're working with as far as this hole's concerned. I don't think I need to fill the hole in at all. It'll be fine like it is. And that's how we come out down here, so we can make that work. Let's get some solder mask on there, and It's easy to put too much on, because what will happen is the top cures in the UV light fairly quickly, and it doesn't give the center a chance to cure, and you can end up with a shell with a liquid center. Sounds like an ad for candy, doesn't it? That's going to go through like that, and I think if we tack that into place for now, just to help with the solder flow down through the hole, because it does actually have to, well, it doesn't have to solder on the other side, but it does bond through the hole. Give it a wiggle, let the solder down, dispose of that. We could fold that over that way. I think I'll just touch up all of the pins on this this IC, just to make sure that it's they're looking a bit scarce on the solder there. Possibly even cracked, because I did bend it a couple times as well. We can use what's left of that leg to bond it back to there. Put a little bend in it so it kind of lines up. Load the tip with solder. Of course, if you work too slowly on this end, it'll get hot and liquefy there and come off, of course. So just top that up a little bit more. That should be enough. I can't imagine this is a high current device. There's a reasonable size pad there, but I'm sure that will be plenty adequate. A bit of ISO. Yeah. Nope. Good thing I didn't wash the numbers off. I didn't know which way around it went. Just give them a squeeze, make sure they're flat in that direction, and possibly due to be tweaked a little bit in that direction. Of course, if you need to practice a few times, just use the wrong side of the board, because there's usually more room to work, and you can just see if it lines up, and there you go, straight in like that. So you know it's going to work easy on the right side and not waste your time. Tricky thing is, I'm going to have to power this up now to know if it's actually achieved anything. I should have tried that before, but I'm sure it would have made a bigger mess if I did. Like it never happened. Let's just check. There's a diode there. I'm just going to test that since it's in the vicinity. Make sure it's okay. If we go, I don't know what way around it is, but we'll just try that way first. Oh yeah, 0.5 volt drop, not a problem. Okay, let's check resistance across the capacitor that we just installed. So it's negative on the outside, so we don't have any horrible shorts or things going on there that we shouldn't have. That's many megohms, understandable. There's another cap on the end here, so we'll just check that one. And then I think I should also, probably should remove it and actually check its capacitance is alright, because I mean that could take off next. It's just as old. There's a little one over here, so let's just see, make sure there's no No shorts on there. I got 50,000 ohms, so I'm happy. ESR meter, and what does it say? 0.4. 0.4 for 100 mic. 50 volt. Yeah, it's getting up there. I think I might just replace that anyway. Turns out this one is a 330 mic at 10 volt, so that's fine. It's still old and crappy. I'm going to put a 330 at 16 volt. No worries. It may have started to leak. It's a little, it could just be old and fluxy, or it could, yeah, just a little something around the pins there. Not surprised. There we go. Much better looking than blue. What was that, 30-year-old blue? Make sure there's no flux hanging around the pins of that oscillator. You don't need anything to upset that, although it's probably quite a low frequency. It may not really matter, but you never know. Awesome. What do you reckon we try power it up? I've identified the two pins that are at least battery always and ground. And initially what I want to do is make sure this regulator is putting out what I assume it should, probably a 5 volt at this sort of level of old processor. This little regulator is an LM2926. Pin 1 is should be our 12 volts in, and pin 2 is going to be our output. Yeah. One thing I did, because if this was it actually does have a lot of protection against reverse polarity, so it probably wasn't that. It probably was just the cap was old and became a short. There would have been a lot of current go through this diode. The battery in goes through this diode and then to the regulator. Yeah, and that capacitor is on our input to the regulator. So it's, yeah, may have been an over voltage, or it might even be ripple. Like ripple from the alternator would really upset a capacitor like that. So I will tell him to check his charging circuit, but keeping in mind the other caps are okay. However, it wouldn't matter, this cap's on the output, so it wouldn't matter. You wouldn't see the ripple there once it had gone through here, I suppose. Would have thought that the diode would somewhat rectify that. So we've got ground as pin 3, so I will connect it and we'll see how much. Hopefully it's got a current limit at the moment, so hopefully it doesn't draw a lot, and it's at 50 milliamps. So pin 3 for the ground and our input, and there's our, was 12.5 because it was dropped through the diode, possibly 2 diodes, and then I'll just squeeze in here and get the output pin. Oh look, 5 volts like I thought. Let's not short that to the 12 volt input pin. So 50 milliamps, and that's looking positive. I do not know which pin is our ignition, which is a shame because I'm pretty sure it's not going to light up as it is. So let's plug it into the display and check anyway. I don't have a backlight. I just grab a torch just in case. So I'll pop the power on. Oh look, it's blinking off. Hey, how about that? Can we turn it on? There we go. It's got a torch behind there. So to turn it on, I suppose we just push a fan button. Ah, there we go. Look at that. Vent. 0, low, 2, 3, 4, their fan speed. Can I change temperature? Nothing showing up for temperature. Oh, if I push auto, there you go. It was in auto mode, so now I can change the temperature. See 17, 18, 19, AC, off, on. Cool. Mode. That should be changing those transistors. Now it works off, I just found out, vacuum solenoids. So the transistors activate a solenoid and then engine vacuum goes through to either open or shut them. And I turn it off. Excellent. Well, I'm going to call that a fix. Also, at the bottom, now there's a pipe that goes on the bottom that the fan, aircon fan, will draw air through, and what it's drawing it through is a sensor down in the front here. And I noticed when I was looking at it, look at that, it's all plugged up with dirt and garbage. You see the little red sensor there, but it's surrounded by black fluff and whatnot, so we're just going to clean that out, and that way they'll get airflow from the cabin through and a more accurate cabin temperature in order to, you know, maintain auto aircon properly. There you go. You can see light through there now. There's our little sensor. No more fluff around it. And reassemble in the reverse order, making sure you line up all the pins. There you go. How much room do they give for that cable at the side? There's actually a slot in the case for the board to sit in. And, I kind of just snake the cables up the side and out beside the plugs there. Got to hold them all to the little notch on the side so they don't get pinched around the connector when it comes all the way through, and then that should seat just like that. Give it a pull, ain't going to come out again. And of course you made note of which light went into which hole, didn't you? I'm pretty sure, I mean, one said ignition, but the wire that it said ignition for in the plug just went to this light bulb. I'm pretty sure it's just the backlight for the LCD itself, so there's a separate compartment there. So we'll chuck that up there. I mean, that is where it was when I got it. And then the other two are actually paralleled inside. They're connected together, so they're going to be just for when you put your headlights on. They're commoned up to light up the buttons. You don't need that on during the day, but you do need to see that screen, of course. So it's been a bit butchered. I noticed it wasn't sitting in the hole very well, but we could probably squeeze that in. I'll have to feed that in with a little bit of persuasion. Squeeze it down the hole. Hopefully that bulb doesn't need replacing. You have to fight with that when he does. There we have the repair of a Fairmont climate control. Maybe the same in a Falcon, I don't know. Could be the same in an EL, I don't know. But there you go. This may be a very common fault, but if it does happen to you, you should be able to follow what I did and come with a similar result. So, thanks for watching, and see you all next time.